Okay, so we are going to work on my homework and learn about Kruskal's algorithm for a minimum spanning tree. And here's the problem. I've already done this this first part, so the goal for now is to focus on part 2, which thankfully comes with some starter code. So pretty grateful about that, because we have to use get direction distance here, which just, you know, finds the direct distance in meters on the surface of the Earth between 2 points, latitude and longitude. So let me just take a second, make sure that everything is running. And make sure that I can getting sound. I wasn't getting sound the other day. Okay, I think it's working. So okay, I guess if anybody checks this out later, just let me know how I can improve. Because I'm new to this, so I'm just kind of getting my setup working. Okay, cool. I'm going to throw on some music just to jam a little bit and figure this out.
Created by Satan to prey on the living, it feeds on your most secret desires and hidden fears. Dormant for centuries,
Okay,
its
so
time has finally come.
I've already started a little bit, but the problem says given the location of 20 isolated islands in the Atlantic Ocean in a CSV file. So a CSV file that I've copied from the material into here. And it's just a list of some fictitious latitude and longitude values for these islands. And it looks like we have entry 0, entry 1, 2, and so on all the way to 19. And we have a latitude and a longitude, so it looks like we're going to need to parse that. And then it says use the Kruskal's algorithm, which was also provided. And that was provided. I think I have that. Oh yeah. Okay. referenced this code in class, and we went over it. I'll have to go over it again. I use my VS Code for React and JavaScript programming a lot, so I have these strange colors which kind of throw me off, honestly, when I'm getting used to using IntelliJ, because it's just get used to the coloring, I guess. Okay, so then we are supposed to use Kruskal's algorithm to find the minimum length of bridges that need to be built between these islands so that people can commute between them without sea travel. Okay. So download the Java method to calculate the direct distance in meters between 2 points on Earth with no latitude and longitude. Okay, so we got that. And that's it. Okay, so let's think about this for a second. It's so funny because it's like, when I program, you know, most of the time I find that I'm sitting here thinking. So let me set a timer. Hey Siri, set a timer for 25 minutes. Okay, great. So we're going to set a Pomodoro timer on my iPhone so that I can break. Okay, so let me get some paper so I can write this down, because I've already done like some input reading here. So I obviously have the code that was given to me that's going to calculate the distance in meters on the Earth's surface between 2 latitude and longitude points right here. So this was provided. Now I need to take the input, which I've got right here, which is going to read in this CSV file with this while loop right here. And it's basically going to read it into an array list, which holds like an array of strings. So it's just like an array list holding an array of strings. And then I need to parse through that. So I'm going to split it on its commas right here, and then it's going to put all of that into this variable, and then that's going to add it to the array list. And I'm going to end up with an array list that has a bunch of arrays inside of it. So as far as that goes, that's pretty straightforward. The only thing I actually think I need to handle is the first line case here, because as soon as I start reading this file, I'm going to actually run into an issue, because it's going to want to read this line that says islands, comma, latitude, longitude, and that's going to throw off everything, because we don't really need that. So I was thinking that maybe I should use a regex expression. There's a sneaky little website called regex 101 that I use, and basically, what you can do with regex 101 is you can, and by the way, regex is short for regular expression, from my understanding, and basically you can match a pattern by telling Java, hey, I have this pattern that is a string, like in this case 0 to 9, and I want you to match this pattern when you find it. So in this case, at regex 101, I type it in and it kind of like gives me a breakdown of what it's going to do. So it looks like it's going to match a single character in the range between 0 and 9. So I'm also going to go to ChatGPT here, and I'm just going to ask it to kind of give an explanation of that too. Because oftentimes I don't explain things very well, and then I don't fully understand what it is that I even explain in the first place. So let me do this so that I can have a more well-rounded explanation. Okay, so it's saying in Java, the string pattern, in this case that I'm using 0 to 9, is used as a regular expression to define pattern for matching sequences of characters or strings. The specific pattern is 0 to 9. Okay, great, straightforward. So, and then it looks like it's going to give us some info on the methods we can use. But I actually used this in my last homework assignment, so I'm going to go back to that and see what I did that worked, because I got 100% on this. So I used it here, and I matched this string, which was a single occurrence string. It wasn't, a range of numbers. So in this case, it looks like I used the pattern object. The pattern object, and then I compiled the pattern. So I think we want to do the same thing with the pattern object, and then we want to compile it with the actual pattern. Okay. We've only done this once before, so let's try it again. So it looks like we're going to use the pattern object, and let's call it int pattern. And we want it to compile the pattern. Okay, cool, simple enough. And remember why I'm doing this is because I need to deal with this first line so that I can tell the while loop to skip over it. So it doesn't see, the common pattern I'm noticing here is all of these lines have a 0 or a 9 in them. So basically and this first line doesn't. So basically, if Java sees that this file we're reading in does not have a 0 or a 9 in it, then it needs to skip that line. So that it'll just give us these lines, and then we can read those in. Then at that point, we can go on to the next phase, whatever we gotta do. So let's now check the rest of the code, and we have then we want to match it. Okay, so if it matches, okay, cool. So let me jot that down. Okay. Matcher object. Interesting. Okay, so I'm just gonna actually copy this. And then over around here, and we're gonna say pretty much the same thing, but we're gonna do it for line in. So let's do that, and then this is no longer regex. This is int pattern. So oh, okay, look at that. We split it first, so we might want to actually not split this quite yet. And just make this 10. Okay, so let's make it 10. And let's just put the 10 here. Let's not split this quite yet. And then let's put the temp here so we can actually read if the temp has the values we're looking for in it. So then we're going to say if my match I wonder if I can check it like that. So what I'm trying to do is I'm trying to check and see if the match actually occurred. So let me see here. Okay, so we want to use the matches method. All right. So if my match dot matches, so I guess that's going to say if this match, which is reading the temp variable, which is taking input from this file, matches the pattern that we compiled here, then do something, right? So, but the thing is, we want to check if it doesn't match, right? Because if we check that it matches every time, it's just actually would make more sense, I think, to check that it doesn't match. So we're going to say if it does not match, then continue. So we can continue to the next iteration of the while loop. But if it does match, then we actually want to go ahead and we want to parse the string. So we're going to go, all right, we're going to go do what we did before, which is we're going to say, make sure I did that. Yeah, good. Then we're going to say, okay, so we've read in temp, so we need a split temp. So we're going to say line in, so we've read that line, equals temp.split, and then we're going to use a regex because this is what it takes. We're going to split it on the comma. So what that's going to do is it's going to return an array using the comma as a delimiter. Okay, so if we look at our file, we're going to say Java, look for the pattern occurrence of 0 to 9 in this input line that we take in. So Java is going to say, okay, I'm going to read in this line from this file with the scanner, and then while there's a next, we're going to read that line, put it in the temp variable, and then we're going to check that line to see if there's a match for this pattern. So it looks like, though, we probably want an occurrence, now that I'm thinking about it, because if we look at this, obviously the first line's not going to have it, but Huh, now I'm wondering, will it check? Let me put this in. Match any single character present in the list below. Okay, so it'll match any single character present. So that should work, I think. That should match any 0 to 9, and obviously since 0 to 9 is not present in the first line, it will match it in the others. So let's roll with that, see what happens. It'll obviously throw an error, because I have it in a try catch, so at least it'll throw an error. Okay, so then we're going to split it on the comma, then we're going to add it to the array list, and then at this point I want to actually just go ahead and test that everything is going to work before I code too much farther. Make sure that my array list is getting filled up like I want it to. So I'm just going to do a for loop. So let's say for string s of array list dot get. Well, I guess I might want to use a regular for loop. We'll just do array list. No, come to get it. So let's say, let's do the old school for loop. I'm so used to that. I have to keep practicing. Okay, so for int I equals 0, I is going to be less than array list dot size, and then we will increment, and then we'll say system.out.println array list dot get index. Get I. Oh, right. It's going to be. Oh, I see. Okay. I have to wrap it in arrays to string because it's actually an array list that contains arrays of strings. It's like Inception. It's just everything's inside of one another. Alright, cool. Alright, well, let's see what it suggests with the enhanced for loop. Oh, okay, so for string array strings of array list. Okay, that makes sense. That was close. Alright, let's see how this plays out. We'll see what happens. We'll see what our output is. And nothing is output, so obviously did something wrong. Although we did finish with a 0, so that's interesting. Okay. Let's do a random print statement to make sure that it's running. Put it out here. And let's run it again. Okay, so why is it not printing? Let's see. What did I do wrong? Let me go ahead and do some basic debugging. And see where I went wrong. So let's print temp. See what it's giving us. Okay, so it is grabbing the file. It is definitely reading the file. Okay. Oh, I see. I bet. Thinking of it backwards. Let's try this. That actually would make more sense. I love programming. It's like when you think you know something, it just is like, nope. You can do better. Okay, so we're getting that. Now let's go ahead and try again. Nope. We're still reading it. Let's go ahead and move this down. So we're reading the line in, and then that's working just fine. And it's printing out each element from the file, right here, including the first line, which, you know, we don't want, but that's what we're trying to address. So let me think. Looks like literally add all of them to an array list and then just get rid of the first element. That would be way easier than trying to match a pattern. Although I think matching a pattern is pretty useful. I feel like it could go either way though. You could, you know, one half doesn't work the other. In this case, it's not like we're reading a file that has like a billion entries, like social media username database or multiple database, and there's all kinds of variable data. We're just reading like 20 elements. So let me do that. That's actually more simple. Okay, so we're going to get rid of this. Although the regex idea was useful in the last assignment, you know, maybe I can make it a little more simple this time. So if we're going to do that, then we don't necessarily need temp either. But since it's already in the code, we'll just leave it. So let's go ahead and do that. It's going to read it in, and then we're not going to do the regex anymore. So maybe I'm just used to using regex because I was making this app for this business to get some more actual development experience, and basically I had to use like regex for like weeks straight, just trying to make people's passwords match a certain pattern. I'm like all on the regex bandwagon. Okay, so we want, but that's a totally different type of programming than this too. This is like more data structures and algorithms, so this definitely requires more thought. Okay, so we're adding it to the array list, we're splitting it, and I want to print it just to make sure. So, looks like we already have that, so let's try it. And here we are. So we have the first element, which is latitude and longitude, and we can pull up the CSV file. So all we did was read it in, you know, pretty straightforward, nothing crazy here. Read it in and put it into an array list after splitting it into arrays. So at this point, I just need to remove the first item. So at the end of all this, I'm going to go other biggest challenge is remembering all the methods and like having to look them up. Okay, so let's see here. We have the array list and oh, this is not the list of methods. So here we go. Oh, break time. Okay, so we need a 5-minute break. Hey Siri, set a timer for 5 minutes. Oh, okay, there's a couple people in the chat. How's everybody doing? Get to watch me work through some data structures and algorithms problems. Learning Kruskal's algorithm for the first time. It's kind of an interesting algorithm, really is. I did do Dijkstra's recently, which was kind of fun. It was really hard. It took me a while. I ended up having to use ChatGPT to like have it explain a bunch of stuff to me because after you like, I don't know, if you start staring at it for a while, it's like you understand a lot of it, but then you sort of have to like get some help because it just gets monotonous. It's not even that one. It was actually this one that I was working on. Oh, it's on my GitHub. I thought it was really cool though. It worked out great. Yeah, it's over here on my GitHub. It's funny, I've actually taken data structures twice. I took it once like over a year ago, just on my own with like a Udemy type class in Java, and that was really enlightening. It was really challenging, but then I had to take it again, you know, now. And they do totally different problems. They didn't even teach us on the Udemy class all the stuff they teach in college. They didn't really go over a lot of the same concepts. But there's still a lot of good information. Here's the full implementation. Yeah, this one's interesting because you're actually taking a graph, you're taking a weighted graph, like and you're actually like, oh, actually, I have a picture. I don't even need to draw it. Here's one right here. Yeah, so you're taking a weighted graph like this, and you're basically finding the shortest path from 0 to any other node in this graph. by its weights. So these little numbers in between the nodes in the graph are the weights. And so like, yeah, it just calculates the shortest path between 0 and every other node. So it's kind of like what people would use when they're implementing like Google Maps, like navigation, you know? It'd be like, you want to find the shortest distance between, you know, here and your destination. You would, you know, they actually implement, you know, algorithms that are doing that sort of stuff. It's pretty interesting. Okay, 30 seconds. 30 seconds. The Pomodoro Technique's really interesting. I haven't got to use it a whole lot. I thought it'd be cool to stream on Twitch and try and utilize it as an opportunity to grow. And maybe other people pipe up too. They can learn more. I have obviously a lot to learn. Always learning. Okay, cool. Now we're going to go back. Hey Siri, set a timer for 25 minutes. Okay, cool. So we were trying to actually look up some array list methods for what we're doing here, trying to remove the first element. So let's see here. I mean, I could just ask ChatGPT, but I also like the practice of reading the docs. Okay, last index is empty. Contains at all. I wish it was like a stack where you could just be like, array list pop. I don't think you can do that though. Oh, well, we can use remove. That's just as good, right? Okay, so let's go here. And after this while loop is done, we're going to just remove it. We're going to say array list.remove. And it wants an index, so 0 is our index. And that says it just simply removes it. Perfect. Let's slash this over here. How do we do that? Alright, now we're going to remove the 0th index. Let's print it, make sure it's working. Perfect. Took it out. Now we get to do something different. Okay, so we now have the array list with all of our latitude and longitudes right here. And we want to basically calculate the distance. And these all need to, so if we want to think about this problem, we can sort of think about it like, probably the best way for me to think about this. Okay. Okay, so we have a bunch of islands, and these islands all have specific latitude and longitude points. So it looks like we have 20 islands. Looks like they're all right here. Yeah, they're all right here. So let me go ahead and copy these and put them in here. And we have the first one here. So that's island 1. And then we're going to just make a bunch of copies here. So let's take this one. Okay. And we'll go ahead and move all of the latitude and longitudes in each of these. So I know that, like I said, a lot of programming is really, for me, is thinking about the problem rather than just jumping right into it with code. And, you know, I've written several web applications. I've even written a couple mobile applications. They're not on the App Store or anything, but it was more for like my own exercise. And some of that stuff you can jump in, from my experience, you can jump in and you can code, but it still requires a lot of thought. And similarly with these data structures problems, you really have to understand the problem. And so that's what I'm really trying to do here, because I clearly don't understand the problem enough that I can just start cranking out code. So I'm going to draw this picture. I'm going to get all of these latitude and longitudes in here so that we can sort of start to develop a better idea of what's going on as far as what we want to do next. Now that we've got our input taken in, and that's all, you know, pretty straightforward. You know, I'm thinking, do we want to calculate the distance next? Do we want to figure out the distance between each island and then put it into the graph and then calculate the minimum spanning tree using Kruskal's that way? Or, you know, is there an easier way to do this? Is there a better way to do this? Initially, off the top of my head, I would kind of lean towards the direction of using the latitude longitude formula to calculate the distance before I put the edges in the graph so that I have all of that. But, you know, I kind of want to look at this laid out first before I go ahead and do that, because it's possible that that's not, you know, the optimal way to do this. There's probably a lot of ways to do this, but, you know, given the problem, what is the best way to do it? What is, I guess, maybe I'm lazy, but the least work? Alright, let's finish this. The word processing part. You know, draw.io is pretty cool, but it's like, maybe their pro version is really great. I don't know, I haven't tried it. I had one of their sales reps reach out to me and they tried to sell me it. I was like, I didn't even know that people paid for it. Okay, cool. So we got these islands. And they're all, you know, a certain distance apart. And we want to calculate. What I'm thinking I want to do is I want to keep that index number in them, and I want to change that to the actual distance in meters once I get it calculated. So if we have an array of, you know, here are 20 values, And we want to calculate them all with respect to one another. You know, I'm sort of thinking we're going to need like a nested for loop, especially since, you know, we're not given any constraints on time complexity. So, you know, I immediately think, you know, we're not trying to do anything really from an efficiency perspective within a certain amount of time. So probably a nested for loop would be pretty straightforward with going through these and then calculating each of the values with respect to its next value. So I don't know, I'm kind of a neat person, so I'm kind of laying these out like this, which is, you know, probably not entirely necessary, but it is for me. So I can more cleanly see what's going on. Okay, so we have each latitude and longitude. We need to measure each latitude and longitude's distance with respect to the next. So if we're doing that, then we probably want to save the distance between for each. So calculating the distance beforehand does not seem like a good idea, because that seems very difficult to keep track of all the edges. And well, in class they taught us, you know, we need to actually keep track of these edges for the graph inside a hash set that has a hash map that has a nested hash set inside of it. So what that means is we need to, you know, think of this as like a hash map right here, and you know, we have our hash map, and then the hash map itself will actually point towards a hash set. So you know, essentially this node, let's say this node was here. It would point towards a hash set, which was a set of all of the values associated with it. So in this case, it would be the node and the edges associated with the node. So if this node had, you know, 20 edges, here's one, this edge actually would represent a distance. We can imagine this edge connected to, well, not this specific edge, but an edge connected to every other node, just as depicted in this other picture that we had. So just like this, we would have an edge, except in our example, we would have an edge from each node to every other node. So every node would be connected in like a fully connected edge web, if you want to think of it like that. So we would need to calculate the shortest path of all of those. And so we would just need a hash set with each of those edge distances. So it would make sense then to potentially just go ahead and, well, let me look at the algorithm. And see how it's actually supposed to calculate it, so that I can see how we might put it in. I know this one says Kruskal, but this isn't the one we were using in class. We were using okay, yeah, we were using this one. And it has the weighted graph type. Well, the weighted graph object, I think that's actually in here. Let's find that. Oh great, so 1746, let's find which one is. Okay, here it is. So that is, where is that? Okay, here we go. Alright, it's inside the utils folder. Okay, so we're going to need that, it looks like, to implement this. So let me go ahead and start building this algorithm up with the code provided. Alright, so I think that I'm just going to go ahead and do a bunch of static classes inside of this Kruskal's class that I made so that we can go ahead and just keep it all in one file, because they're going to want us to create a zip file. So I'm going to just go ahead and copy the code provided from class, and we're going to start moving it in here. This is going to be a lot like what we had to do with some of the Dijkstra algorithm. Okay, so it looks like we're going to need to make this static. And then we're going to need the vertex class, which I'm pretty sure is kind of like the node class. Yeah, that's it. Okay, so we're going to take the vertex class, and we'll go ahead and put it down here and make it static. Okay, so all I'm doing is I'm just reusing code that, you know, we went over in class, that we built in class, that there's no sense in rewriting again. And so basically, that's all we're going to do, is we're just going to reuse this code. I don't really want to write it again. I mean, we spent the time and understood it once, so, you know, not here. I don't want to redo all that work. But we can go over it. Let me get all of the rest of the code in, and then I'll just kind of do like a quick once over and just go through it. So at least we've gone over, and anyone who watches this might be able to like just catch up on that. So let me go get the graph class, which you can see on my other code editor. Like I said, I have IntelliJ I use here for, you know, more Java specific things, and then I have VS Code, which is more like what I use for like React and JavaScript, TypeScript, things like that. So let's take the graph class and get it in here. And let's make that static so everything's aligned. Okay, great. Now what are the ones we're missing? Okay, that's not an issue. The return value is never used. I'm pretty sure we use it in a way. Okay, that's fine. Let's make sure these other ones are up to date. Okay, adjacency map. Adjacency matrices are kind of cool. Okay. Okay, I'm not seeing any obvious issues. I think that there are some other methods that we're going to need though, because okay, right. Yeah, there's like a print solution which we're going to need. Is this? Oh no, that takes a list of vertexes. Okay. Let me make sure that that's not in here. I don't think it is. It might be when we actually bring Kruskals in. So let's try that. So we have Bellman-Ford's algorithm. So Bellman-Ford's algorithm and Dijkstra's algorithm do something pretty similar. So imagine, again, graph. So this is a graph. So I know like a graph, sometimes people also think of like this. You know, you have your x-axis, you have your y-axis, and then you have some function, and you know, your function does something, right? Maybe it goes in a straight line, maybe it goes in a curve, maybe it's quadratic, maybe it's cubic, maybe it's whatever, right? So keep things simple, think of like a straight line, think of a linear. You know, y equals mx plus b, which is actually used heavily in large language models as far as like the GPT type models. With initializing the weights. Funny, they actually use that same formula quite a bit when talking about weights. Anyway, that's way over my head. I know only very little, so I just find it very fascinating. Anyhow, this is also a graph, but we are talking about these type of graphs. And in this sense here, we are talking about Bellman-Ford and Dijkstra's algorithm. So Dijkstra was a very famous computer scientist back in the 1930s, and he got a lot of notoriety for developing this pathfinding algorithm that everyone knows as Dijkstra's algorithm. And what it does is it finds the shortest distance within a weighted graph that has positive edges. So when we're talking about a graph, we have vertices, which are these green dots, and then we have the edges, which are these lines in between. And these edges are weighted, which means they have a value associated with them. Now these weights can be positive, they can be negative, depending on what the use case is for the graph, but generally speaking, Dijkstra's algorithm here, which this is only part of it, by the way, it's actually a lot more to it than just that, will find the shortest distance between any. So this graph could have 1 million nodes, right? It can have like 1 billion nodes. It could be like every city on the face of the planet, right? And then there's a distance between each one. So this 1 would be like New York, and this 0 would be like Seattle, and this 6 would be like Miami, and this 8 would be like, I don't know, London. This 3 could be like the South Pole. I don't even know, I'm just making stuff up. But the point is, there's distances in between these. This Dijkstra's algorithm will actually find that shortest distance and it will return that to you. So you have a starting point and find the shortest distance. So if you're like, I want to find the shortest distance from New York to whatever, but maybe let's say you have New York as 1, and then you have Seattle as 2, and then you have Miami as like 3, and then you have, since I'm from Denver, I'm going to put Denver in here, you have Denver as like 6, and you're like, okay, well 0 is, let's say Los Angeles, and then 7 is like Dallas, right? And you want to go from New York to like Denver, then basically you need to find the shortest path. Is it from 1 to 7? Is it from 1 to 2 to 8 to 6? Is it from 1 to 0 to 7? Like, what is that? So that's what Dijkstra's does. But the thing with Dijkstra's is these weights have to be positive. They can't be negative, or it won't work right. And that's where we have Bellman-Ford's algorithm, which handles the case where these are negative values. Now, when we're thinking of distances between cities, you're not thinking of like negative, right? There's not like a negative distance. But when you get into, more higher level science, which I study computer science, so I don't know necessarily the specific use case for this off the top of my head, but you probably could end up with theoretically some use cases for some negative distances, or in the case of like kind of going back to large language models like ChatGPT, these weights could be negative depending on how they like initialize them, or the values within the nodes and the relationship between them, those could be negative weights. So, Bellman-Ford's algorithm might be useful in, instances where they have negative weights. Anyhow, Kruskal's algorithm is pretty similar in respect that it finds the shortest distance. And it looks like I need to take a break too. Hey Siri, set a timer for 5 minutes. Okay, so what I'm going to do, find Kruskal's. Oh, okay, somebody's talking in the chat. Sorry if I missed you in the chat. Oh, Cartesian graphs. Yeah, Cartesian graphs are really interesting. I remember I studied Cartesian graphs like 2 years ago. Those were really interesting. Let me pull something up on Cartesian graphs. Actually, let's ask ChatGPT to explain Cartesian graphs to us. I hate how ChatGPT just wants to give you the answer. Like, I think there's great info here, but I don't always want the answer because I want to solve it myself. Okay. Cartesian graphs. Okay, these are coordinate systems. Displaying data on two axes, or axes, in a two-dimensional space. Okay, Descartes. Descartes is credited for their development. Okay, Cartesian. Okay. Isn't there like, I'm trying to remember, isn't there like a way to essentially calculate between like Cartesian coordinates and linear coordinates, I think it is? I don't know. Let me ask. So like, is it like a conversion? Oh, okay, interesting. Okay, transformation. Okay, so transforming between Cartesian coordinates and linear representation often involves converting between different forms of equations. So we have standard form, which is slope-intercept form. That's going to be, you know, the y equals mx plus b. And then we have the, okay, well that's ax plus by equals c. Okay. And then in linear algebra, Cartesian coordinates are used extensively to represent vectors and perform operations such as vector addition, scalar manipulation, and finding linear combinations. Okay, that's cool. Man, it's been so long since I've studied that. Very interesting though. Yeah, vectors. Vectors are... Where would we be without vectors? Let me just say that. We would be in the Dark Ages, probably. Well, maybe not the Dark Ages, but we wouldn't have a lot of cool things, that's for sure. We wouldn't have this. We wouldn't have ChatGPT, that's for sure. ChatGPT uses vectors quite a bit. Although, like I said, I'm not an expert on that. I just know a little bit, and I find it very fascinating. Cool. Alright, well, let's get back to this. 5 seconds. Hey Siri, set a timer for... Hey Siri, set a timer for 25 minutes. Okay, so we were actually looking for Kruskal's algorithm over here. Okay, here it is. Alright, so we have Kruskal's. Okay, so I'm gonna drop that in yet. We got vertex, weighted graph. Oh, we don't have that yet, so we're gonna go ahead and bring Kruskal's in. So yeah, this is the tree, minimum spanning tree algorithm. looks like we're going to need the edge. Yes, this is what I was trying to do, was look up the implementation here of this, because that's going to help me understand more clearly of essentially how I need to approach getting the data that we read into this algorithm. So did I get it all? No, I'm missing a curly brace. Okay, so we're going to use the disjoint set also. Yeah, Kruskal is pretty interesting. It looks like he uses the disjoint set. Okay. So let's find the disjoint set. It sits right here.
I just wanna stay in the sun where I find. I know it's hard sometimes. Pieces of peace in the sun's peace of mind. I know it's hard sometimes. Yeah, I think about the end just way too much. But it's fun to fantasize. All my enemies wouldn't.
Yeah, and after I get all this in, I'll go over I'll just follow the code and we'll go over it. So it's like,
So I'm taking my time on my ride. I'm bored, so I'm taking my time on my ride. Taking my time on my ride. I died for you, that's easy to say. We have a list of people that we would take. A bullet for them, a bullet for you, a bullet for everybody in this room. But it don't seem to see many bullets coming through. Too many bullets coming through. Metaphorically, I'm the man, but literally, I don't know what I do.
more room for improvement.
It's hard to do, even harder to say when you know it's not true. Even harder to write when you know it's another. There were people
Okay,
that
so everything is static, so it should
all these questions they're falling like, would you live for me? Would you die for it? Would you ever give?
okay.
I'm bored, so I'm taking my time on my ride. I'm bored, so I'm taking my time on my ride.
Oh, okay. It looks like he already did the implementation with a different data set, so okay. Interesting. So we just need the weights. Okay. Just separate these. Okay. So now, okay, let's go over this code. I think all of it's here. Yeah, everything's here. Okay, so let's start at the top. Okay, so, which ironically is going to be bottom of this code. So we have the implementation from class, which uses starting here. So all of this up here was the code I wrote a little bit ago and went over for reading in this file, this CSV file. So that's done, and you know, it's printed here. So now we're going to manipulate it using Kruskal's algorithm. But first, let's understand what's going on. So we have a weighted graph. Okay, so what is a weighted graph? Well, I've spoke extensively about weighted graphs, and here is a picture of a weighted graph, right here. So it looks like in order to implement the code that we have from class, we are going to need to be supplying the weighted graph class with an array of strings, well, 2 arrays of strings. One representing the vertexes, so vertexes in the case of this picture would be, 1, 2, 8, 3, 5, 4, etc. So in this example code, which is not in alignment with our current situation, but it's just an example, we have 7 vertexes, and we also have sets of edges between those vertexes, which appear to be between vertex 3 and vertex 1, an edge of weight 4. Between vertex 3 and vertex 6, an edge of weight 5, and so on and so forth. And then it looks like we have an edge array after the weighted graph class. Well, we have an array of edge objects that are being given back to us after we pass the actual graph itself to the Kruskal algorithm. So let's take a look at the weighted graph class first. Which is right here. So it looks like the weighted graph class uses the edge class, and it wants to return an array of edges, which makes sense because that's what. Oh wait, that's the Kruskal. Here we go. Okay, yeah, that makes more sense. So we have the weighted graph class. It looks like it has a map that has a vertex and then another map inside of the map with the vertex mapped to the integer, or the weight rather. So, that's going to be kind of like this thing that I was drawing earlier, where we have the vertex, which is this, and then inside of this map, which is this box of boxes, we have another map, right, which has the vertex pointing to the weight. Okay, so I was used to using the hash set. Okay. So all that's going to be is okay, so I think that is just taking this, and I think it's pointing towards its associated vertex. We can look at the vertex class as well, but one vertex points to another, and then the edge that's associated with that is what it also points to. So we would have, in this case, if this edge was, let's say this edge was like 5, then this would point to 5. And then if there was another one of these, which there will be in our implementation, because it's a map, it's going to have, another edge, this, except this one's going to be like, I don't know, maybe like 7, and then this is going to be, this is just an example, obviously not exhaustive. Would be like this. So it would be kind of like that. So we'd have like this pointing towards this node, pointing towards another map, which would have that vertex and that vertex, and then those would point towards the weight. So I think it's also an undirected graph, so it means that it could go either way with the direction of these edges. Okay, so then it looks like, oh, okay, it extends the graph class. Oh, I already got that. It's already there. Okay, so we can hover over this. Oh no, here it is. Okay, yeah, it's down here. So it implements this, which again, oh, here we go, the graph set. Alright, so it's the weighted graph is implementing the actual graph class for extending that. So, okay. Okay, cool. So the actual alignment of everything inside the hash set is happening inside of the graph. Okay, then we have instance methods. This is, this actually keeps track of the number of edges that come into a graph. I remember going over that. And then there's some stuff for like depth first search, which we're actually not making use for this. Okay, cool. So the weighted graph is just implementing the graph class, or extending the graph class using its methods, but it's also setting up its own management for the weights. So that's why the weighted graph class takes the vertices and the edges, and it takes those as string arrays, because then it's going to, yeah, it's going to go over all the edges here in the for loop, and then it's going to set the weights. Okay, cool. Then we have the edges. So we want to check this out. There we are. Okay, so it's going to implement the comparable interface. And it's going to compare the edges. Okay, that makes sense because we want to know the minimum spanning tree. Okay, cool. So, since this code was already pre-made, we're pretty much going to be stuck with using the implementation that's already provided. There's not really any sense in trying to change all this. It would just be I think it would kind of defeat the purpose of what we're trying to learn here, which is implementing the instructor's code. So what we need to do is we need to actually get all of the weights for all of these. So we need to calculate the distance between 0 and 1, 0 and 2, 0 and 3, and so on and so forth, and then 1 and 2, and then 1 and 3, and 1 and 4, and then 2 and 3, and 2 and 4, and so on and so forth. So I think that we just need to do like a nested for loop is sort of my thought, and then we need to basically we need to manage those distances somehow. So I'm trying to think of a good way to manage the distances between each vertex so that we have it laid out in a nice manner like this, and we can essentially pass that into this code. So, because I mean, we can actually run this and it should run fine. Let me double check. It looks like I'm getting an error somewhere, or I can run it and it'll tell me where my error is. Looks like it might be here. Yeah, let me see what. Yeah, see, it's already running this setup. So, and in the case of this graph, this example graph we have, it's already calculating everything. So I'm going to go ahead and do some pseudocode for how we want to manage the allocation of the weights for each vertex, because we have, 20 vertexes, and we need to use this formula here to get each distance. So let's do, so the first thing that comes to mind is to make a nested for loop. So for the first element, and again, I'm just pseudocoding this on a note card right now, so for the first element of the list, or the array list, we want to calculate the distance between each other once. So for the first element of the list, iterate over every other element. Okay, so all that's going to be is something like 4. This is an infection in that element. That one, and at the last element. Okay, so for each element of the list, Okay, great. So for each element of the array list, we will iterate over each element. Now, because we have arrays inside each, that actually is nice. So iterate over each element. Because we want the latitude and the longitude. So for each element of the list, we need to get the lat and long. Okay, so because we need to use that to calculate. So these are strings. Yeah, because it's a string array. So we're going to need to say, we're going to need to convert them into, let's see, probably just floats. I don't see any reason to use double, although we could use double. Okay, so we're going to say float, let's use double. Double equals get I. Okay, so it's going to get I. I is going to be the string, but we want the array value inside of it. So how am I going to say that? Let's do this. Let's break it down. We're gonna do string s, and we're gonna get I. Okay, so that's gonna give us a string that is string array. That's gonna give us this element. Then we're gonna say, I was trying to think of how I could say it in like one single statement to like not have to do like multiple lines, but whatever. Sometimes you gotta do multiple lines, especially while you're learning. So once we have the string array s, then we want to get the first and second element. So we're gonna say double element 1. Okay, so we gotta take a 5-minute break. Hey Siri, set a timer for 5 minutes. Okay, cool. So I found the Cartesian graph conversation pretty interesting. So I don't see anything else in chat at the moment. I can double check. I don't think I have. Check. Oh, okay, somebody on TikTok was chatting. Okay. Okay, sweet. Yeah, let's go back to the Cartesian graph, because that was pretty interesting. Oh, look, there we go. Perfect. Thanks, C. Crooks. I appreciate that. Thank you. Yeah, so back to the Cartesian graph. That was really interesting because we're on the 5-minute break. I really liked the Cartesian graph topic because I haven't looked at it in so long, it was refreshing my memory, and I was really enjoying relearning that. So let's see here. I think this was the most verbose explanation. So yeah, the Cartesian coordinate system and the concept of linearity are closely related, but represent different aspects of mathematical representation and analysis. So the Cartesian coordinate system, by definition, according to ChatGPT, is a coordinate system built on a geometric framework that uses numerical coordinates to represent points in a two-dimensional plane. So let's go ahead and let's look up what one looks like. Perfect. So this is going to be pretty standard Cartesian coordinate system, and I think this is something that, you know, a lot of people get exposure to, especially when studying, you know, linear graphs. So when we go back to our explanation, so linearity refers to the property of a mathematical object or system that obeys the principles of superposition and homogeneity. So the characteristics of this are going to, at least in the context of functions or equations, mean that the function satisfies the following properties. And this can be, you know, I'm trying to like really make this as simple as possible, more closely related to the point slope or slope intercept equation. In this case, y equals mx plus b. So I think point slope is actually going to be a little different. Point slope is how we're going to find, it's a different form that's going to allow us to you know, find the intersection of the axes. So, by the way, I really like this guy. I always see his stuff. He's the organic chemistry guy, I think, on YouTube. This guy's great. Yeah, he's really good. I've watched a lot of his stuff. Anyone that's really wanting more definitive explanations, go watch this guy's stuff. He's great. I love this guy. His explanations are very thorough, and I've actually watched so many of his videos as I've gone through a lot of my own studies. Okay, cool. So I'm actually curious now, since we're talking about graphs from a weighted graph perspective, what ChatGPT is going to actually do if we try to do a compare and contrast between, you know, the Cartesian graph versus, you know, more of like a weighted graph, like what we're trying to navigate here. So let's ask it. And this is also GPT-4, by the way. It's not 4.0. Although 4.0 is good, I've noticed that 4, which I get from my Plus subscription, is gives out sometimes some additional information, which is pretty useful. You don't always get on 4.0. Okay, cool. So we're doing compare and contrast real quick, and then I'm going to get back to Pomodoro. So Cartesian graphs and weighted graphs, you know, looking at their definitions, serve different purposes and are constructed with unique features tailored to those purposes. So, you know, we just went over the Cartesian graphs, where each point is in a two-dimensional plane and is identified by unique x and y coordinates. Characteristics like the x and y axis, the origin, 0, 0, And the use of the coordinates are based, really in a two-dimensional plane where you have x as one dimension, y as the other. And these are good. This is actually pretty good. Geometric and algebraic analysis is the types of data that they represent. Now, weighted graphs are a type of graph where each edge has an associated weight. These weights can represent various measurable quantities such as costs, lengths, or capacities, depending on the context of the graph. So these are going to be more prevalent in algorithms. Tools associated with, algorithmic analysis, or things requiring weights that carry values. Read more about that. The theory is very interesting to me. I always learn something new. I really like it. There's so much, it's like, spend a lifetime learning just on graphs. I remember one of my professors, he was doing his PhD in graph theory. And at the time I was like, graph theory? Because we hadn't been introduced to graphs yet. And I was like, what are you going to do with that? Now I'm like, light bulb comes on. I understand it all more clearly. Hey Siri, set a timer for 25 minutes. Alright, perfect. So now back to this. Okay, so we're iterating over this. We want to grab the first and second elements. So we're going to make this a double, which means we're going to have to essentially cast it. We're going to have to do a typecast. So, well, we could probably just do... S1 will be, we should probably name it something a little bit better, because that's actually going to be the latitude. So it's actually a string right now, so we want it to be a double, so we can do... what is that method? The wrapper class. Now let me do this. I'm going to break it down individually, and then I'm going to condense it. Alright, so there's the lat, there's the launch, that's going to be S2. Remember, those are strings, so... why does it like that? 0, 1, 2. Interesting. I wonder why it didn't like... Oh, it's because long is a reserved word. That's why. So let me just call it longitude. Forgot long is actually a type. I don't use it very often. Okay, so longitude. Okay, so those are strings. Now we want to do... is it? It's like value of. Yeah, it's value of. Is that it? Oh, it's parse double. Okay. It's parse double value of. Okay, that's what it was. Yeah, I'm just gonna like stretch this out and then I'll condense it so it's a little bit more readable. Sometimes I have to do that where I'm like, where I stretch it out over a couple lines, then I can condense it. Maybe as time goes on and I practice more, I'll get better. Okay, cool. So let's see. Let me do this. Okay, so we can just do this. Oops. There. I got it right the first time. There. Okay, so we got that. Now we want to do... Well, we're going to want to get that for the next ones too. So we're going to want to jump over here in the second for loop. And basically get the latitude, longitude for the next value, which in this case would be here. So we're going to do basically the same thing, except we'll just change the variable name. So we'll do lat first, long first, and we can do first. That makes more sense to me. And then we'll do the second. Okay, cool. The only thing though is this is going to be J, because remember J is I plus 1. So if I is 0, then J is always the next element. So if I is 0, then J is 1. If I is 1, then J is 2. So we'll always be grabbing the subsequent element as we iterate. So for the first loop, we'll have I is 0, J is 1. So it'll grab the first two, latitude and longitude. So we need to change this. So we'll just call this S2. Then the inner for loop will continue to the next iteration. Increment J, then J will become 2. And it will grab the latitude and longitude of the second element, and then we will calculate that distance. So we're going to actually have to take each distance, and we need to keep track of it. So How do we want to keep track of it? Well, my first thought is maybe to keep track of it in the string format, kind of like this, from how the professor has demonstrated he wants us to implement the code. So I'm thinking that maybe I just build a string, like a massive string. Well, I just wouldn't be that massive, but you know, I'm learning, so it's massive to me right now. Yeah, maybe just do like a string builder. I haven't used string builder a whole lot, but I'm definitely aware of its use. Although we probably want to move this up inside the catch statement or the try statement. I'm thinking about it. So let's do a string builder, and let's learn about string builder in the Java docs. Probably want to start it with, yeah, let's go to Java docs and let's learn about string builder. Okay. String builder is interesting. It's actually a little more versatile than just concatenating the strings together, which is kind of cool. Okay, so it looks like it has 4 constructors. Okay, so initial capacity is 16. Like we can append a lot of things to it, okay? We can append objects, we can append strings, character sequences, even buffers. Okay, cool. Okay, well, it looks like all we're going to be doing is appending strings. So we'll do the calculation and then turn it back to a string and then stick it back in there. Okay, so and it looks like all I have to do is sp.append whatever I want. Okay, cool. So, given that, all we want to do is, we'll probably have to append like some commas and stuff to it, since this is parsing it by commas. Okay, so let me pseudocode this out a little bit. And just think about this for a second. Alright, so we're getting the first element, and then we're iterating over every other element, and we are getting, so we get the first lat and first long. Then we get the second lat and the second longitude. Oh, and by the way, before I forget, I'll probably post all this on my GitHub too if anybody checks this out later. And once we get it working, I'll upload it to my GitHub. So if you want to make it better and, like, you know, improve it, then by all means you can cruise over to my GitHub and I'll share that later. And you can download. There's a lot of other interesting stuff on there too that's fun to mess around with. Okay, so we got the second latitude and we got the second longitude. And now that we have those, we want to go ahead and we want to actually calculate. So we've turned them into doubles, which I think is the type that we need. Yeah, these are doubles. Okay. So we want to call get direction or get direct distance. So, and that's going to return, is it going to return a double? Yeah, it's going to return a double. So we want to calculate distance. Okay, once we calculate the distance, which is going to be here, calc distance, then we want to save that in a variable. And then we want to append it to the string builder. I really like strings, by the way. Strings are probably my most favorite data type. I don't know. They're just so versatile. Everything I do, I think, is in strings, and then I just convert. It's so much easier, in my opinion. After we convert it, or rather append it, then we want to go ahead and format it. So that it fits this format. So we want to format. But I think maybe we want to format it before we append it. That probably would be important. So we're going to calc distance, then we're going to save it, which is kind of implied, but I'll write it down anyway. Then we're going to format it. And then we're going to append it. Okay, so seems pretty straightforward. Let's go ahead and grab the name of this method that we're using. And that's going to return double. So I'm actually going to just copy the signature of it so that I don't have to keep looking at it. Okay, so I'm going to do this too. I'm going to keep renaming the variable, but I don't know. I like to have variable names that are like more aligned with the signature. Just saves me time later, especially when I have to debug and I have to go look at it. And I'm like, okay, why did I name that variable like some weird name like second long? What does that even mean? Why didn't I name it long2 or lat2? That seems more sensible. Chasing down variables that you gave weird names is like, oh man, that's like, I hate that. I'm like, why did I do that? Alright, then we're going to pass it lat1. And long1, right? Yeah, lat and long. And then lat2. Long2. Oh, and I just want to iterate one thing too. The point of the current algorithms class I'm in is to be implementing algorithms, not necessarily calculating things. You know, I did that back in calculus where we calculated a lot of things, and that was great. But now it's kind of nice because we're not calculating things, the computer's calculating it. So we get to use the formulas rather than having to make them, which is amazing. I was so tired of doing integrals. By the time I did integrals, I was done, man. I was so tired of that. It was great to know and all that, but I haven't used it yet, so hopefully I'll get to use it. Alright, so got that. Now we want to format the string. So distance is going to be in meters. So this is going to be, each time it iterates, it will be the distance of the outer for loop's value to the inner for loop's value. So what that means is we sort of want to take one of these strings, since we're, you know, going to be wanting to have it in this format, and it's going to be like, think of like, I'm thinking like vertex 1, you know, that'll be the equivalent of the outer for loop's I, and then vertex 3 in this case. Now in vertex 1 in this example instance, it'll be inner for loop, so inner for j, and then dist. And these cannot have spaces, so let's do sb.append, and looks like it's going to give us some options, although I do want to refer to the docs. Yeah, okay, cool. So SB equals sb.append, and we want to append a sequence, so we're going to do v, and then we're going to do, I wonder if I can do this, plus I. Can I do that? String concatenation as argument to string builder call, replaced with chain append calls. Okay. I guess that's easier. Although, let me just type it out so that I get the refs. Append I. Okay, so that should not. Actually, here's one thing I want to know, and this is actually where ChatGPT is pretty useful. I want to know if this is actually going to append without a space. I mean, I could run it and test it, but this will be quicker. Will string builder append with no spaces? Yes, it will append. Okay, great, thanks. Alright, cool. So ChatGPT 4 is pretty good for that, actually. It's pretty good on these little small things. I know people are like, whoa, well, it gives you bunk code. It totally gives you bunk code, by the way. I have got some crazy-ass code from ChatGPT before, and I look at it and I'm like, where did you even come up with this? But for simple things like this, it's usually pretty good. It saves me time to not have to like run it, then debug it to figure it out. Okay, cool. So we're going to append that. That's going to give us the V, and then I is going to represent the current index. So if we are, you know, at index 0 is going to be 0. So this will equivocally end up at something like V0. And then for the next iteration, it would be like V1. So on and so forth. So we're going to append that, and then we're also going to need to append comma, and then we're going to append another V, and then we're going to append the next vertex, so the vertex that we're connecting it to, or we're, measuring the distance between. So that's going to be J. And then we need to append another comma. And then we need to append the actual distance, which in this case is dist. So, although dist is, will that automatically convert it to a string? Maybe we should convert it to a string first. Okay, let me convert it to a string real quick, and then I will. I think it might do an implicit cast to a string. But maybe it'd be nicer if I just did it. Yeah, we did this before. Double dot to string. Perfect. Alright, cool. 5-minute break. Hey Siri, set a timer for 5 minutes. Okay, cool. So, that makes sense. Okay, so there's still more chat. Let's say I remember doing discrete math last year, so let's talk about discrete math. Discrete math is interesting. Where we have like contrapositives and what were the other ones? Like logic tables, truth tables. Yeah, discrete math was super interesting. It was a lot to remember. I think one of the exams they let us have like the equivalent of 1 page of notes. Which, I mean, honestly, with all that stuff, I mean, it helps a little bit, but not a whole lot, so it's nice that they let us have it, though. Alright, let's talk about discrete math. Yeah, it was like truth tables and logic, and I should get my notebook out, actually. I have a whole huge notebook on that. That was where we first learned about graphs. That was fun. Oh yeah, proofs. We do a lot of proofs. Yeah, I remember the proofs now. Oh wow, yeah, here's all my proofs. Okay. So, assume the square root of 2 is rational. You have to prove that. So, first of all, you gotta know what a rational number is. And I think that was like one of the first things that we went over was they were like, you're gonna need to refresh your memory on rational numbers, irrational numbers, real numbers, integers, natural numbers, etc. So an irrational number is a number that cannot be expressed as a over b. So basically, you can't express it as a fraction, non-terminally, with non-repeating decimals. So let's get some like very well-known rational numbers. So, pretty straightforward. 1/2 would be a rational number because it's not repeating. It's not a repeating decimal. It's literally 0.5, and then it's done. It doesn't keep going. So, for example, like what would that mean? That would be pi. Would be pi would not be a rational number. So that continues on and on. Another one would be like 0.25 because it ends, so 1/4. So in that case, you're like looking at this proof and you're like, okay, so prove to me that square root of 2 is irrational. That's the question. Sure glad I kept all these notes. I don't miss proofs though, that's for sure. It's a lot of work. Oh, and Boolean algebra. Boolean algebra was actually really interesting. There's a lot of like truth tables. Okay, well, as much as I would love to dive into that more right now, the timer's up, so maybe on the next break. Hey Siri. Hey Siri. Set a timer for 25 minutes. Yeah, maybe I can look at that more on the next break. Now I'm all interested in it. I'm like, oh yeah, now I remember. I like to keep all my notebooks because there's just so much information. It's like you can remember the high-level concepts and what you did, but the level of detail you go into in this stuff, just, I mean, something as simple as, assuming the square root of 2 is rational, like, I mean, that was like half a page for nothing like I did in calculus. We were doing like 4 pages of like integral calculation for one solution. But, for something like that, it's like still very high level of detail. So now moving on to programming, we are building this string. We have taken this double and we have turned it into a string, and we've got our distance between 2 points that we used this handy dandy formula that the professor gave us, and we calculated the distance. And I mean, I kind of want to go ahead and print it out to make sure that we're getting the correct setup. So now that we have the string builder, putting everything together in the proper format, we're going to want to go ahead and essentially put that into an array list. I love array lists, by the way. They're just so nice. Regular arrays in Java are just very static, but array lists are so nice. Whoever invented the array list, thank you. Thank you. So let's go ahead and set up our array list outside. And this is just going to be an array list of strings that are formatted for how the algorithm, the Kruskal's algorithm that we have is going to, be looking to take that in, to ingest that. So let's just make a new array list. And this is going to be a string array list. And we'll call it our formatted nodes, or vertexes. It's not even really that, it's like our formatted values, it's just format. Okay, cool. Now we're going to put that in. So I think add just adds it to the front, or does it add it to the end? No. Add first. It's not like I put that in this thing. Just set. Right? What's the best method? There's obviously lots of options because there's a million ways to do the same thing in programming. So let's just try and find an optimal option. Set is going to replace, so we don't want to do that. Okay, so add is just going to add it at the end of the list. Okay. So that's fine. That should be fine. Oh, okay, so we have to wrap it because it is the string builder, so we have to convert that into a string. Okay. That makes sense. So we should now be able to print it out. Outside. So let's go ahead and do that. For string S, remember that. I'm so used to doing it this way. I've been doing it this way for years. It'll change it for me though. I think it changed it for me last time. Because it's like, print it out. I'll have to change this later because my professor hates it when I do these. It's always 0. Let me try this. Actually, I'm going to do that. Just do it here.
I make money when I talk.
Makes more sense to do this anyway.
I can introduce you to the plug. Bitches see no Henny in my cup. Stay down, not a rash up. She gon' let me fuck ass up. Plug. I stuck keys in the Louis V. Fuck 12, I'm a G, ain't no stopping me. And my wrist is on overseas. Rich nigga, you can talk to me.
It's saying that. Interesting. Alright, let's print it out, see what happens. Probably don't want to print all that though, at least not this time. Let's give it a run. Oh, okay, so I did get a index and a mouse, but I got it at the very end, so I'll just have to adjust the length. Okay. Okay, so we have the distance. Okay. So it's appending the 0, then it's appending the 1, then it's appending the distance, which also like make it no space here. I'm just having a hard time like seeing where it's stopping and then where the next value starts. Okay, so format looks good in general, other than it needs to be an array of strings. So that's actually going to be pretty easy though, I would think, just because if we want it to be an array of strings, then I love the split method, by the way. The split method is great because all you got to do is use it and then it gives you an array. So I'm just going to append I'm going to append like a plus sign at the end because that's pretty easy to use as a delimiter. And then I'm going to do the array list as a string array list, and then I'm going to have the SB get split, the string builder gets split into an array on the delimiter of the space, or sorry, the plus sign. So we'll do string array, string builder array, and that's going to be SB dot well, it's actually going to be string dot value of SB dot split, I think. And then we're going to split it on the plus side. Or do we not have to? We'll try without it. Look at the split of this. Maybe I have to turn it into a string first. To string. And then we could just do dot split. Yeah, that makes more sense. We'll put it in the array. And then we'll have the SB temp get added. But because we already turned it into a string, we don't need that. And that's a regex, so it has to be single parentheses. No? Okay, let's try something different. Doesn't like the plus sign, so we'll use a slash. Okay, cool. So that's going to do that, and then we're going to do this. So it adds it. Space here. Okay. So now I'm just going to print them out. Let's see. Okay, well we can just print out SB. Although I kind of want to. I don't know why it's telling me. I mean, I'm obviously doing something wrong. Why is it telling me that that's empty? what happens. Maybe it'll give me an error. That'll help me understand what I'm doing. Not really helpful. I don't know why that's not. Let's see if we can learn something there. Ah, that's what I was doing. That would make sense. I was incrementing I and not J. It was just a typo. For some reason I typed I there instead of J. Let's see if it does anything different now. Well, I'm not getting the same problem, getting a different one. Let's change these. Okay. So that looks correct. This is fine. Oh, it has to do with this. It was just double dot parse double. So it wasn't actually... Okay. See, I make it too complicated, I overthink it. Okay, that makes sense. And then we are getting J here, not I. And then this is correct, that's correct. Just a couple simple errors. Okay, cool. Very simple errors. It's always like that though. Alright, let's see. So we got a lot of stuff now. No errors. And it's printing the array, which is perfect. So we have, I'm going to make this the whole screen because there's a lot to check out here. Okay, so we have V0 to V1 is this distance. The V0 to V1, yeah, same repeated. Okay, that's great. So after we do that, what, however many times, 20 plus 19 plus 18 plus 17 plus 16 plus 15 all the way down times, we're going to end up with V0, V1, V0, V2. It should be V0 all the way to, should be V0 all the way to V19. Let's make sure it did that. say V0, 17, 18, 19, and then V1 to V2, so then it moves to the next. Okay, that's good. Okay, and that's a string array, so we can literally just pass that to our algorithm here, and it should be fine. I mean, I do want to check to see how it's reading it in though. So when we go to weighted graph, because then as far as this is concerned, all we'll have to do is abstract the 0th element of each. Not exactly. We could put that in manually. It would actually kind of make sense to put that in manually just because we wanted to only calculate certain nodes. But how is the weighted graph class reading in second input? Okay, so it has so it's using the superclass, so it's using graph. Okay. So yeah, it should be fine. I mean, I could just iterate over all of these and get the first element and put it in its own array, but I don't really see the point in doing that if that's not what we're supposed to do. I mean, it technically doesn't even tell us that we're supposed to like read in the file. Find the minimum length of bridges. Yeah, I mean, it's... I feel like I'm doing more than I'm supposed to already. Okay, back to the street math for 5 minutes. Hey Siri, set a timer for 5 minutes. Okay, yeah, so we were talking about proofs for a second. And we were talking about irrational versus irrational numbers. So the proof that we were talking about was a proof of the number square root of 2 is rational. So, is irrational. So this was actually a proof by contradiction that I was using. And we basically had to assume the opposite, essentially assume the contradiction, which if the statement is saying that the number root 2 is irrational, then the proper way for a contrapositive proof is to assume that root 2 is rational. So by assuming the contrapositive in this, the contradiction in this case, it allows us to essentially compare root 2 to a over b such that b is not equal 0, and a and b are elements of integers. So by doing that, we were able to begin the proof and essentially do a little bit of algebra at that point. Square both sides. So we would have like root 2 equals a over b, such that b does not equal 0 and a and b are both elements of the integers, and they have no common divisors. So we would square both sides. We would end up with 2 is equal to a squared over b squared, and then a squared is even. We were going to assume that a squared was even, because that would essentially allow us to, so by, let me back up. So by multiplying b squared, so we have 2 equals a squared over b squared, and we multiply b squared to end up with 2b squared equals a squared. We can then assume that a squared is even, and therefore if a is even, a common property of every even number is, if you multiply it by 2, you're going to get an even number. So if you take any number and multiply it by 2, you get an even number. It's just like, kind of like a rule, like a law, basically. If you take 1 times 2, you get 2. If you take 2 times 2, you get 4. If you take 3 times 2, you get 6. So on and so forth. Every number times 2 will be an even number. So we assume that a squared is even, therefore a is equal to 2k. So we introduce k, the variable k, in the proof to essentially mathematically state that we're using some other like number represented by this variable k that's not a part of our original statement. Then we do a little bit more algebra, break it all down, and then basically get to the result that implies b squared is even. And we basically apply the same premise to b. B equals 2l. Now we introduce another variable l, such that l is not a part of our original statement or any subsequent statements. So we're implying that l is now newly introduced, and we notice that basically this root 2 being rational is false. I mean, it's proofs. You're just basically taking known statements, comparing it to your statement, introducing variables using very basic rules of math, like rules of integers, rules of real numbers, rules of irrational numbers, etc., rules of positive numbers, rules of negative numbers, to essentially prove your statement is either true or false, and then they ask you to like assume the contrapositive or assume the contradiction, or in some cases, well, that's for indirect proofs. For direct proofs, you can do, you have like your hypothesis statement in the same sense, but you're not assuming like the inverse. So it's just a lot of like very detail-oriented steps to prove the result is what your original statement was stating. Okay, cool. So now I'm going to set up for 25 minutes again. Hey Siri, set a timer for 25 minutes. That discrete math was interesting. I really liked, honestly, even though calculus was a lot of work, I really liked that just because it was like more like, it was like less theoretical than what you get in discrete math, which was a lot more interesting to me. Just like how all of that's used is very intriguing. Okay, so now we have our array of strings that represents formatted the value of the start vertex, or excuse me, the representation of the start vertex, the end vertex, and the calculated distance using our formula. So now that array is set up, so we can actually go ahead and pass that array in here. So one thing that we can do is take the formatted values array and move its scope up so that it's accessible to our code below. And let's make some space. And then we're just going to basically set a new, probably just set a new array, and then at the end, copy all the values. Okay, so I'm just trying to think now. The best way that I want to go about copying the array list into the weighted graph class. So I have this array list, and it's getting the formatted values array list, which has all of these string arrays added to it. So I want to do this, because I think I can just grab the last one. So we're going to go formatted values dot size, and then the last one. So let's try that. Make sure that's going to give me what I want, which looks like it is. Scroll all the way over. Yep, it's going to give me what I want. So that is going to be last element. So all we have to do I don't even know if I have to. I wonder if this will print the memory hash forfeit will print. Yeah, it's not gonna like that. Okay, cool. So that will get that. So all I'll have to do then is take this. This, and it should how do I want to put that into that? The other thing is it has all of these spaces in it, which I don't want. So I'll just make a new string array that is that, and then I'll just put it in there. But I gotta remove this space, because that space isn't supposed to be there. So we'll just do
Tell the dogs I bring it back, it was a silver fade. Before no Cardinals, baby girl, she paid the tourist guide. Got the keys into my city, now she notarized. Got new money, got new problems, got new enemies. When you make it to the top, it's the amenities. Packing out Toyota like I'm in the league. And it ain't a mosh pit if ain't no injuries. I got him stage diving out the nosebleeds. She hit that booger sugar till her nose bleed. Bouncing shit forever, she on both knees. She was talking about forever, got a whole week. But she know my baby mama is a trophy. She be throwing up in beats, feel like they both bleed. She keep my dick jumping out, feel like I'm Moby. I'm way too gold for this beef, feel like I'm Kobe. Yeah, this right here is astronomical. I see you picked up all my ways, I feel responsible. They're trying to say that all my problems is improbable. They keep itching at my spit, I'm diabolical, you feel me?
the replace method is part of that. Start and
Bitches, we the best music. Another one.
check that.
DJ Khaled. Bitches calling my phone like I'm locked up non-stop. From the plane to the fucking helicopter. Yeah, cops pulling up like I'm giving drugs. Nah. I'm a pop star, not a doctor. Bitches calling my phone like I'm locked up non-stop. From the plane to the fucking helicopter.
So I want to replace all of the spaces. If I have the string builder, then I can just do split it, add it to tent. I can just remove it. Yeah, I'll probably just do let's be temp dot replace, and replacing spaces with an empty string. I wonder if I could just do it. This, I do that. No. Maybe. Use string array. I don't want to do that. See, that's the thing, because it's in the string builder, so could do like sb equals sb.toString maybe. No. Alright, let me back up and think about this a little more. Okay, so I have a string builder. I want to essentially take the string builder string, which is not technically like a straight up string, and I want to turn it into a string so that I can, you know, basically operate on it real quick, because I'm noticing that I have these spaces. So my thing is that if we have the spaces, where are they getting added at? That's sort of my question, because I'm not noticing any obvious place where I'm adding an empty string, so it must be happening inside the split method. That's the only place that, because I mean, if I print SB, I can check. Let's see. I think it would be worth at least printing it to see if it's doing it there. And then go from there. So let's see what it does. Okay, yeah, so it's printing it without any space. So it's taking the, it's actually taking the slash, and when it splits it, it's actually adding a space in. So what we need to do is we need to operate on the last element of formatted values, because that's really the only array that we want. So let's do that. Let's just go ahead and we have the line in, which is no longer being used. So maybe we'll just make a new one, and yeah, it's probably just going to be, it's probably pretty redundant, but given the current setup, we'll just do that, just so we can get it done. String array, this is going to be the finished string. Well, it's not technically finished. It's going to be the last index. And then we're just going to grab it right here. Yeah, that's the last index, so that's turning it to a string, so last index. And then we'll throw that down, and then now that we have the last index, which is just a string array, we can pretty easily mess with that. So we'll just say last index, spell it right, last index equals last index 0 dot replace, see if I can replace the space with an empty string. Let's see if it likes that. Nope, it does not like that. Well, okay, so it would just overwrite. New string array. Okay, well, if that's the case, then we don't even need this. So we can just put this here. Doesn't like that. That's fine. Okay, well, we can just print it out and see what it says. And last index. And that's just going to be a simple concatenation, last index. Okay. Oh, we have to actually do the arrays to string. Arrays dot to string. Let's try that now. Still, okay, so let's do this. Okay, so what? Let's back up real quick because I grabbed the wrong one. Okay. Okay. Ah, I see. I missed that other part. Okay. So, yeah, that's what we want to do. Okay, let's try. Then, alright, so we're use 10. Okay. Then we'll do that. Boom. Now it puts it back in an array. Which we've declared there. Okay, perfect. And then we can print. That should work. I feel like that'll work. Okay. Now, let's try. I just want to test what my values are. Because I have an idea in my head of what they are, but I want to make sure that I'm thinking of it correctly. Because I sort of like I sort of have an idea in my head, but the idea in my head versus what comes out sometimes is not always the same. So I want to make sure that I'm, just doing my due diligence. Okay, so it's doing that. Okay. So it likes that. It's probably just because last index I made is a string array, so this should work fine, and then I can basically just pass it that way, because now it's a string array. So that's all I have to do is this. So we'll just, oops, I'm gonna keep that. And then I should let's see here. So this is the edges, new string array, and it's passing that. So we don't really need all of those. So I'm just gonna, if I can. It's out of scope, that's why. Okay, so let's go back to the variable we made that is in scope and just change it to a string. And then use that so we can access it in this class. So okay, so we're going to make last index equal to this mess. And then that should place it within scope and should still give us, the exact same value. It should just say last index here. Okay, cool. Yeah, that's good. And then all those spaces are gone, so it shouldn't have any issues. So now all I need to do is just get rid of these, although sometimes I don't like how it does this formatting, because it's like kind of annoying. Okay, so we don't want that. Okay, so now we can do last index. But it doesn't like that. Why is that? Oh, okay, because it's saying it might not have been initialized. All right, so let's just make it an empty string, so it's not, so Java's not all mad about that. Although it's still. Oh, I see. Okay. Okay. So formatted values. Okay. So I'm still missing a step here, but I'm getting closer. All right. Let's try this. So if formatted values. Okay, so we split it, we appended the backslash, and then we split it, then we turned it back into a string. So we could take the space out that was put in there by the split. Okay, then we printed it out, and it's a string now. For some reason it has these strange things on it, so it has these brackets. So let's replace the brackets with an empty string also. And we're going to replace the end bracket too, because I'm pretty sure there's probably one at the end too. I think it was because I had it inside of an array list, and it was an array of strings. So let's go ahead and do this. Also an empty string, and then let's print it out and see that it comes out. So let me actually copy this, because this is going to freak out on me because of this thing. So we'll fix that so that it goes back to where it was. So it's not freaking out. And then we'll just paste that. Make sure we initialize this back to an empty string so Java's not upset at me. And then we'll print out the last index. No errors this time. It should run and should take out that little bracket. Yeah, it took that bracket out. Okay, cool. So now make sure the bracket at the end's gone. Yeah, that's gone. Okay, cool. Yeah, it added these little brackets because I had put the string. I think this is why it did it. I could be wrong. Somebody can correct me certainly, but I feel like it added the brackets because I put the string inside of an array and then put the array inside of an array list. So I think it added those. Because the array list was an array list of strings, it took the bracket that was around the outside of the first array and then actually converted that to basically be part of the string, is what I'm thinking happened. Now I don't know if that's true or not, but regardless, we wanted to use the array list because it gave us these convenient methods for iterating over all of these and adding them in. We didn't have to deal with resizing of the array. It was all happening dynamically. That's why we were choosing that. As opposed to having a regular array, we would have had to, I mean, we could have just calculated how many slots it needed. Because we had a static amount of data, but realistically, the array list still is easier because it's dynamic. It alleviates that extra step. So we used the array list, and I think that we used it for its convenience. Ultimately, I think it added in that bracket we had to remove. So now I think we should be good. This is a string, and then we're essentially getting rid of all of those brackets. Now we still have this space. Oh no, we got rid of the space. So really all we need to do is we just need to oh, I see what the issue is now. Oh, okay. Now we actually kind of went backwards. Okay. Because of that. Look at that. How funny. How funny is that? Okay, because we split that. Out of that space. So then we wanted to remove that space. Okay, so we split that, and that gave us that. And this from the 4. Okay, let's back up just a second. I want to double check. Okay, and then we did that. So that we were only getting the last one. Interesting. Okay, but we don't need to do that because we've already done it. So we can print that. Yeah, it should just print the last one. Okay, it's fine. So that is a string. Let me do this. This is probably the better way to do it. I was trying to use all the built-in methods, probably because I'm used to using JavaScript and React. So I think I'm just going to need to basically iterate over this and put it in its own array, because that'll get rid of these. Yeah, that'll probably just be a lot easier. And then I can pass it off, and then that'll basically be the end. Because we've already tested the algorithm, everything's there. All I have to do is get this and then pass it off. So I less than formatted values dot size. Okay. And then we'll just put it into a new array, which is going to be well, we don't have to do that actually, because it's going to be less than, it's going to stop anyway. Yeah, the only time that would make sense is if we have to do it with less than equals. Okay, so so it's just a string array. Just do this one. Like this. Forgetting. Why am I forgetting all of this? I don't know why. Doesn't like that. I'm going to need it outside of this scope anyway, so it probably makes sense to put it up here. Final, I think, is, yeah, you can't use that word. We'll just use prepared. Okay. And we'll actually make it this size. That should be good. Oh, we can't do that because it's... Okay, so we are actually going to calculate it. So... Okay. Yeah, so our formula is, I just had to look up our formula. So I remembered a tree with n vertices has n minus 1 edges, right? But I couldn't remember what the formula was for an undirected graph with 20 nodes. So our formula is going to be n times n minus 1 over 2. So if we have, so it'll be n equals, and I'm doing this like right here, n equals n minus 1 divided by 2. So that means we have 20 islands, right? According to the problem. We have 20 isolated islands. So we have n is 20, so we have 20 minus 1 divided by 2. That's how many slots we have. So that's like 190. Okay. Okay. Then we're going to just put all of those in there, which we can do, because we have this already, so not even necessary. So string array formatted. Well, it already has a string array, so we can just do the one we just created, which is the prepared string array, and oh, okay, let's see what that's doing. No, I don't want to do it every single one, so we actually just want a string of, just a string of this thing. This was okay, yeah, it's that. All right. There we go. That should, for string, doesn't like that. Oh, I see, because it's going to do, I think we do want this. Okay, let me do this. I don't know why I always get this like that. It's just, okay, so we're going to go over okay, I is less than like a single array, so wouldn't that be length? Okay, yeah, so that's what we're doing. I was trying to get into the array list to get the last array of strings in the array list, so I can go over that. So that's why I had to use this loop and not the advanced for loop, because I'm going into the array list, getting the last index of the array list, which is a bunch of strings. There should be like 190 of them. 190. Yeah. Then I'm iterating over every single one of those in that final element of string, that array of strings. And then I'm getting those out. So should work. So getting the last one, putting it out, then we're going to say this. Formatted values dot get the last element dot get the formatted values dot get so get the last one. Okay, so yeah, get the last one and then get the first index. Okay, yeah, that seems right. Try it out. Okay. It's just weird because it's like a very nested array, which is pretty common, but sometimes it's like you gotta really think about that. It's like, how is it in there? Okay, so we're just going to print the strings. It should just print strings. So we'll call it just S. S of prepared string array. And then we're going to print S. I don't think I need that or that. To make sure that it's not like attaching a space again or like something else. So S is, and should print, you should print a line for each one. Oh no, it's mad at me now. I don't think that's going to do it, but I'm kind of curious to see. Okay. So length 9. Let's try this again because this was working. Okay, so that is a string. So Okay, I think I'm going to take a break. So I'm going to take a break and get a snack. So I will throw this on intermission and I will be back. Okay, much better. All right, let me look at this again. So we're getting this out of bounds error. Okay, this might be the issue. All right, I did not type this in correctly. It should be 20 times 20 minus 1, since the formula is n times n minus 1 over 2. So let me see if that fixes it. And let's run it again. Oh, perfect. Okay, so that seems okay. So it took out the space. Yep, looks good. All right, cool. So actually minus 1. I think I need that last one. The last one's null, I think. Yeah. Yeah, it was just I just typed the formula in wrong. Forgot the first multiplication part. Alright, cool. So that's... Is that getting it right? So doing the 18th one? The 18th and 19th. Something seems weird. Let's take a look at that again. Because it should... So I'm seeing I have it at 17th and 19th here, but if I go all the way over here, I have the 18th and 19th. So for some reason, it's not grabbing the last one, which could have to do with this. And yes, that was exactly what it was. So, yeah, I was just stopping one too soon. So, okay, cool. Got that, got that. Seems to be making the array correctly. Make it out. So, let me just print it out on a single line. Make sure there's no weird things going on with it. This is... That's what I want. This is yeah, you don't want to do it like that. You just want to do a print statement with this array dot toString. That's all I want to do. Okay. And yeah, seems fine. Because if I... Yeah, it seems fine. Copies it in. Yeah, that's fine. Okay, cool. Matches all the values. After they're formatted, gets everything I need. Okay, great. So then all I should need to do is pass this. I think I'm almost done, which is nice because I have to go work out. It's like almost that time. Okay, great. Move this. I just needed to get some food. I was like brain dead. I'm just sitting here like, can't think. Alright, sweet. So that should work. That should work. This copies it in. Just when you think everything's good though, you get taught another lesson I've always learned. So while I may be cheery and upbeat at the moment, I may get a massive error of death here in a second. So let me go ahead and I'm going to manually add all these. And the reasoning for that is simply because what if you wanted to only calculate certain vertexes? You know what I mean? Like certain vertices. So you would have that control if you did it manually. In this case, there's also no instructions to say that. So I don't really want to parse it up any farther either. I will say parsing is not bad. It's just you really have to like grasp what you're doing. You know, the funny thing is, this kind of parsing is actually very very nuanced. For like applications I've actually made for like real life projects, the parsing is a little different because typically you're parsing stuff that's not. I mean, unless you're doing like scientific stuff, which I don't do a lot of that. I do more like business application stuff for my business. So it's kind of like you're parsing names, you know, or you're parsing like an age, you know, so you're parsing like non-mixed values, and you're not necessarily running formulas on them either. So, but I think there's a lot of value in this kind of data manipulation, because I think the way the world's going, there's just going to be more and more of this. So I'm grateful for the opportunity to learn it. Alright, sweet. So we only have 19 nodes. Well, 20 technically, but... Alright, 1, 2, 3, 4, 5, 10, 11, 12. Good. Alright, well, let's see what happens. I don't know why it does this. Make sure I comment out my other... Okay, cool. Let's see. Yep, see? I did something. Did not like. Oh, I see. For input string. Okay. Number format exception. And this is happening in parse int at line 22. No, 320. Sort of rigid. Okay, so here, probably up here. Yeah, it's not an int. It's actually like a double, which kind of makes me wonder. Oops. How that's going to affect the rest of everything. So. I think that in the algorithm I want to go ahead and actually just make them. Because I think that we're trying to find like the distance minimum length of bridges. Okay, well, let me follow this and see. Set weight. Okay, so then it's got to take an int in the weight. New weight. Weight.get. Okay, so weight hash map. Yeah, I'm gonna change it to an integer because the entire algorithm depends on integers. I don't really want to change everything to a double, and it doesn't tell me I need to do that, so I'm just gonna do that. So let's do this. It'll cut off the actually, I can't really do it like that. So I'll probably just we just want to turn it into, so we calculated it, got it back. Double to string. Okay, we'll just do it here. Yeah, we'll just typecast it. Okay, cool. So we'll just typecast it into an int, turn it into a string, and then try it again. Oh, sweet. It looks like something happened. Let's see. Okay, so it looks like we have the distances from the islands. So from vertex 6 to vertex 8, it's going to be 11,012 meters. So let's draw a picture since we're basically at the end of this now. Alrighty, okay. And this, we have 19 vertex, so we've made all these already. So, what Kruskal is going to do is it's going to find the minimum spanning tree. So, So that means it's going to find the shortest way across, I think is what. Let me make sure I'm reading the code right. Where is my other code? Okay, I don't think I need one of these things. I want to make sure I'm not. Okay, let me just draw a picture. That'll probably help. Okay, so because I've been in like conceptual thought, now I kind of want to think of it more tangibly. So I'm going to go ahead and like label these. Oh, well, they're already labeled. Okay, cool. Just going to create a little space so they're not so close together. Okay. Yeah, it's funny, the whole thing. I just needed to cast that into an int. I suppose if it was like a real world application, then I would actually go through and like, you know, probably change the algorithm so that it was taking the right type, you know, a double in this case, instead of a int. But I mean, given the scenario, an int seems to be fine. So, okay, cool. So we have our islands, and they all have these distances. So what it's telling us is from 6 to 8. Let me make sure I'm reading the question again so I'm answering it properly. The minimum length of bridges that need to be built between these islands so that people can commute between them without sea travel. Okay. So I guess I'm wondering why or how it determined it was going to use, because we're asked to use this code. And use Kruskal's algorithm, which he gave to us, which is what I'm using. And I'm like wondering, I'm just trying to understand what the interpretation is correctly of this given the current setup. So it's an array of edges. Draw it out and see what it's telling me. Sometimes I'm just like looking at the data on the page after it's printed out and I'm like, okay, what does that even mean? And it's like, not that it's like impossible to understand it, it's just like you have to like sit here and really think about it. And most of the time, I'm kind of like trying to do what I can to not have to think extra hard. That way, when I do have to think extra hard, you know, I'm ready. Because otherwise, it's like, I'm not trying to stress myself out. Okay, so we have 0 to 8, which apparently is 2,688 meters. Okay. No, this is actually an undirected graph, so I probably should not use arrows indicating a direction. That's probably a good place to start. So again, 2,688. Okay, and then 0 to 17. Okay, 0 to 17. Now, why did it pick 17? Why did it not pick 0 to 1 and 0 to 2? That's what I'm wondering. Is that... But I'm also thinking of what Dijkstra's was doing when I had to do Dijkstra's the other day. Because Dijkstra's was more like printing it off in a very logical order. Well, the function that was printing Dijkstra's off was printing it in a very logical order. But in this case, the order is not immediately apparent. So I'm just going to go ahead and connect everything so we can see what it's talking about. That was wild. We connected that. Okay, and then 6 to 8. Okay, so that's 11,012. Six to 8. So it's like, why did it go over here? That's what I'm wondering. Is it supposed to do similar processes what Dijkstra's did in regard to... I'll have to like look at my notes again. And then 6 to 11. Six to 11. Okay. Maybe it's just the way it's printing. So vertex 4 to 13. Okay. I'll probably look up after I do my workout, I'll probably just, I feel like this is right, because this is even though I don't necessarily because I'm just learning Kruskal's algorithm, like I said, Dijkstra's made way more sense because it was more straightforward in that it was finding the shortest distance from a single point to all the other vertices, right, within the graph. So you had a start point, and then it would measure the distance to every other vertex based on the weight of the edge. So that was pretty straightforward. However, this one, so the minimum spanning tree is not necessarily the same. I'm actually going to ask ChatGPT to describe that. So aha, okay. Very similar, but very different, interestingly. Okay, so I think I have this in my notes too. I would have to bust my notes out. But basically, the concept of a minimum spanning tree and Dijkstra's algorithm. So again, Kruskal's algorithm, which is what we're using here, is used for finding the minimum spanning tree. And Dijkstra's is used for finding the shortest path. So the minimum spanning tree and Dijkstra's are both central to graph theory, particularly in the context of network design and pathfinding. However, they serve different purposes and operate under different principles. This sounds like my professor talking to me. Here's a breakdown to clarify the differences and applications of each. The minimum spanning tree. Definition. A minimum spanning tree is a subset of edges. So this is our subset. Is a subset of the edges of a connected, edge-weighted, undirected graph that connects all the vertices together without any cycles. Okay, and so a cycle is defined by basically a graph having a circle in it, in the sense that okay, so let me just draw what a cycle would be like here. So basically, a cycle would be where you had a graph that had a direction, let's say from 2 to node 10 in this case, and we went from node 2 to node 10. Okay, then we went from node 10 to node 9, and then we went from node 9 back to node 2, right? Or any combination of something where you create a circle, basically. That's a cycle. So Kruskal's is finding a non-cyclical path in that sense. So again, a minimum spanning tree is a subset of the edges of a connected edge-weighted graph, just like our graph. A connected edge-weighted undirected graph that connects all the vertices together without any cycles and with the minimum possible total edge weight. That is, it is a spanning tree whose sum of edges weights is as small as possible among all the spanning trees. So if you think about it, we have a graph that has 190 connections. So what this algorithm's done is it's tested every single one of those connections instantaneously and returned to us what the shortest distance is. So in the case of our problem, we have a bunch of islands in the Atlantic Ocean that we want bridges between. You know, we got some civil engineers out there on some barges and probably some, I don't know what they use, some other boats maybe, and they're out there trying to like figure out, okay, well, how do we build all these bridges? Or maybe like down by the Florida Keys. That's a good example, right? Maybe not in the middle of the Atlantic Ocean, because that's seems kind of dangerous, actually. But down in the Florida Keys, if anyone's been to the Florida Keys, the water's usually pretty calm unless there's a hurricane. But it's really pretty, and you got all these like islands that they're trying to connect with bridges, so you obviously don't want to build bridges arbitrarily, you know. I mean, you want to maximize your construction costs. Probably you don't want to build long bridges if there's shorter distances of bridges that would cost less in materials to build. I'm not a civil engineer, so I'm just making this up. But I would tend to think that if you built a bridge that was 5 miles long versus a bridge that was 6 miles long, it would be less materials to build a 5 mile long bridge than a 6 mile long bridge, and that might, or in this case we're using meters, but the metric system, but that might actually be less expensive solely from a materials perspective, possibly a labor perspective too, and might be more advantageous. But the point of that is not to talk about construction. The point is to say that we are trying to find the shortest distance that will achieve an interconnected like graph without having cycles. So you're not like, you know, building multiple bridges to the same island, which, you know, it's not what you want, not in this case. So let's continue building it out, and then we can also look at Dijkstra's. But that one's more simple. Well, I guess just to sum up the minimum spanning tree, the main goal of this minimum spanning tree is to minimize the cost of connecting all nodes of the graph, like I just talked about. It's used in network design. Common algorithms for finding minimum spanning tree called Kruskals, which is what we're using, and prims, which I've used prims in like another class for something else, but can't remember what. It was a while ago. Characteristics only applicable on undirected graphs, and focus on connecting all vertices with lowest possible cost. Does not provide a path between any two specific vertices. Rather, it ensures all vertices are connected in a cost-efficient manner. Okay, cool. Dijkstra's algorithm is a graph search algorithm that solves the shortest path problem for a graph with non-negative edge weights, producing the shortest path from a single start node to all other nodes in the graph. So it's pretty, see, that's a lot more like straightforward. That's why I was getting confused, because I was like trying to remember the definition, and there it is. So I'm going to finish connecting these because I want to make sure it's right, which I'm sure it is, because I mean, generally at a high level it makes sense just looking at the code. I'm not like trying to dive into it at a low level and see where everything's going, which, I mean, honestly, especially for this, unless I'm told to do that, I don't really see the point. But we are now connecting, so we do want these to be pointing in a direction. Well, not necessarily. It actually is just connecting them. So 0 to 8, we got that. 0 to 17, 6 to 8, then 6 to 11, Then we have 4 to 13. Then we have 14 to 17. Okay. 14 to 17. I'll just bring that down. This is what I love about computer science in general, and just, I mean, in general science, but it's like the definitions to some of these things are just so, they're deep. A lot of them are just really deep, and you know, you can remember some of the easy ones, but a lot of times after you get in the code and you're like, oh, okay, I'm making this code work, or I'm, you know, trying to execute this hypothesis, or whatever I'm doing in science, a lot of times, I don't know about everyone, but for me, sometimes I forget what the original question was. Then, like, over here trying to solve it. Or I forget the definition, I'm like, oh, okay, what was that? I got like another 2 weeks, no, like week and a half for my last exam, so I got time to study. I'll probably finish this up, and that's the next thing to do, is take the practice exams. I really like to take the practice exams cold, though, without any studying, because it really gives me an idea of my weak points and my strong points, and it gives me an opportunity to really reveal those in a way that I'm able to really clearly see what I need to spend most of my time studying. And right now I can definitely tell, already off the top, I really need to work on the definitions and what these particular algorithms are for. Where's 16? Oh, there it is. Okay. You know, like what it is they're designed to solve. Meaning, okay, so Dijkstra's is shortest path. All right, great. That's pretty easy. Okay, well, what about prims? Okay, well, what about Bellman-Ford? Or what about Kruskals? Or what other ones are there, you know, that we were studying? I know those are like off the top of my head the primary ones, but I think we had at least 2 or 3 others. 3 to 12. Yeah, and there's always room for improvement. It's never like you've arrived either, you know. That's the one thing. It's like people are sometimes just, there's misgivings about what studying science in general is. It's like it's a constant pursuit of learning, growth, because it's like nobody knows everything, you know. And even with a lot of the foundational concepts, like you can get yourself in a position where, you know, you can remember what some of them are, and, you know, maybe remember quite a few of them. But to really get in the nitty-gritty of it, where you're sitting here and you're actually breaking it down step by step, and you're really executing on every step, or not just that, but you're remembering the details and intricacies of the problem itself, It's, you know, it's challenging. Always learning something new. It's always a very humbling process, which I think is really valuable. Nobody knows everything. Although some people really like to think that they do. And I mean, can you blame them? I don't blame them. I wish I knew everything. Okay, so we got 13 to 18. This is... I'm doing this just so I can check, because I want to make sure. I don't want to turn this in without having checked. Although I trust the code that my, you know, professor gave me, I still want to check. I mean, realistically, you could be like, I bet they do this maybe at like Stanford, or maybe like MIT, they're like, maybe, I don't know. They're like, oh, okay, we're studying Dijkstra's. Why don't you just go ahead and make that? And let us know when you're done. They don't do that at my school. They're like, here, we're gonna like go over it, and then you gotta make like part of it. And then you gotta implement it, and then you gotta like prove you can implement it and use it, and then we're gonna talk about it. They don't like make us just go do it. Okay, so 13 to 18, and then we had 3 to 18. Man, this is, it's gonna be a mess by the time I get done with this. It's feeling like that's gonna be what happens. There's gonna be lines everywhere. Uh, 3 to 18, not 13. Okay, cool. So now we're going to go to 7 and 10. Where is 7? There it is. 10. Okay, and that one is... It's a long distance, 31,590 meters. How many miles is that? Let me ask ChatGPT and see if it's even accurate. It's thinking. Okay. It says 19.58 miles. Well, I might have to double check that, but that's what it's saying. I asked GPT to do like basic addition one time just to like see how good it was. I mean, it did okay for like a couple numbers. Once you got past like a handful of numbers, sometimes it started making really ridiculous mistakes. And I was like, this is supposed to be the AI that everybody in the world is like freaking out about. And it's like, I mean, honestly, it can't even do like a handful of addition. I mean, you give it like what did I get? I gave it like 50 numbers. It messed up like halfway through. And I was like, this is better that I do it on my own. The funny thing is, like, GPT is really interesting. Well, that whole class of generative pre-trained transformers is what they are. It's an architecture. I actually made some feed-forward neural networks. They're on my GitHub if anybody ever wants to check it out. But I actually used them, or not used them, but made them with the assistance with prompt engineering. But the point is, all it is just probability based. It's like after I studied probability, I remember just kind of going over the probability intervals and the way that that's used in artificial intelligence is quite interesting, because it's like all you're doing is typing in a sentence or a phrase or whatever. And by the way, a lot of these apps that they have out there nowadays, they're all just using ChatGPT. There's only like actually 3 or 4, there's a handful of actual large language models that all of these businesses, we're talking about Canva for like social media stuff. We're talking about, let's see, what other ones are there? There's that business plan software called, why can't I think of the name of it? Anyway, it uses AI. You put your prompt into it and it gives you like, I don't know, like paragraph stack that you put in a business plan. But the point is, like, all this software that's out there, even the stuff that you're seeing at code editors and the stuff that you're seeing online, like, it's all stemming from like a handful of the same AI models, which include ChatGPT, which is OpenAI, which is basically owned by Microsoft, and now Apple Intelligence. So we see Apple Intelligence that came out recently, or they're putting better AI into their iPhones and into the MacBooks and into the iPads. So, now I'm going to have in my MacBook and my iPhone and my iPad, I'm going to have Apple Intelligence. You know what that is? It's ChatGPT. They literally struck a partnership with ChatGPT, which is owned half by Microsoft, and they're going to put it in all their stuff. On Twitter, Elon Musk went off about it. He was like, if I think it's absurd that Apple, as massive of a company as they are, and as successful as they have been, they cannot seem to figure out how to piece together their own large language model and implement it on their devices. I think that's wild, especially given the massive influence and the amount of money that Apple has. It's just like, why can't you figure that out? Elon Musk figured that out. He's got Grok on Twitter. You can go talk to Grok, but you gotta pay. You gotta pay for a premium. I've never talked to Grok, so I don't know what it's like, but apparently I've heard it's entertaining. Also, Facebook has the open source Llama models, which are also quite interesting. They just recently released a 300 billion parameter Llama model, which actually is as good, if not better, in some metrics as GPT-4. And by the way, for anyone out there that's like tech oriented, there's also multiple GPT-4 models. You just don't see them in the general public. They actually have like 2 or 3 of them. If you connect to the API, like directly to their servers, you can access multiple variations that are even better than regular GPT-4. It's interesting. I think you can actually access them too through the API console, which you don't actually have to connect directly to the servers to use. So you can check that out on OpenAI, which is pretty interesting, because those models are noticeably better with certain tasks, for sure. But all they're doing is they're taking an input, and they're calculating the probability that the answer you're getting back is the right answer.
So, that's it. It's just a probability based on the sentence. They turned a word or a sentence into a multi-dimensional vector, and they've been able to essentially, through a very complicated process of multi-dimensional vectors and dot products and regression and statistics. There's a lot of stuff involved in that. But the point is, they're able to come back with a probabilistic outcome to your input. So if you say something to it like, "Hi, how are you today?" then it's going to actually turn that sentence into a multidimensional vector, pass it through its algorithm, and then it's going to come to a probabilistic result. And it's going to say that there's a 90% chance, basically, that the best response to this input from this user is, "My day's good, how's yours?" Or, another response to that. It could come back with a number of probabilistic outcomes for different responses to that. So that's basically, in a very high level and rudimentary nutshell, how it's working. It's just calculating a probability based on your input. Is it technically AI? I mean, technically it is. It's a neural network, but it's like, I don't know. It's kind of like rolling a dice. What's the probability that if you hold your hand 6 feet off the ground and drop the dice straight down, that you're going to get a 6, versus if you held your hand 6 inches off the ground and dropped the dice, that you're going to get a 6? It's just going to be a different well, in that case, the probability is, probably the same. But the point is, it's just a probability. It's not like it's thinking for itself. That's the interesting thing to me, is once they can actually get it to write code on itself, which, I guess in a sense would be more closer to that whole singularity concept that people are talking about, then you might start to have something that could, I don't know, at a very, I don't want to say think for itself, because I don't think that's necessarily accurate either, but it might be able to actually learn on its own more effectively. I don't know, because it's just, right now, it's kind of like, I look at GPT like rolling a dice. I don't even necessarily look at it like actual artificial intelligence, because while it is kind of artificially intelligent, it's also like, you could put the same response in twice and get 2 totally different answers. You could put what's 2 plus 2 and get 4 one time, and then you could put the same thing in there the next day, and if you had a different conversation context built up, where you had now they have memory with it, all it does is just save pieces of your information. I don't know if it's reintroducing those into its attention mechanisms that sort of kind of attach themselves to your input, but it's basically just a probabilistic outcome. So you could essentially give it the same question twice in a row and get 2 totally different answers. So I find it very interesting, and I think it's actually overall a good thing. So, my speculation is definitely not meant to be negative. It's more just I don't think it's going to take over the world. I think that a lot of the fear that's being passed around about it is misplaced, and I think that, honestly, I think overall it's a good thing. I think it can actually help a lot of people who, to be honest with you, might struggle with learning certain concepts and need more time or more attention. I can definitely attest to that when it came to certain things that I was learning, where I felt like I needed more tutoring in a sense. And let's say tutoring resources were scarce or hard to come by at the time. I've used ChatGPT for those type of resources off and on quite a bit. And I found it pretty helpful. I found it pretty helpful, especially when it comes to programming concepts. I think that, you know, my guess is that it's pretty decent at programming and you know, software related concepts, data structures and algorithms, you know, things like that, because it was made by programmers, you know, so you would like to think that it's probably really good at that. It's also been trained off of a lot of GitHub data. I mean, when they say these models have, you know, 1 billion parameters, or like Facebook Llama 30B, 30 billion parameters. I actually made an algorithm, again, through the help of prompt engineering, that went into Facebook's Llama model and pulled all the weights out of it. And I was able to kind of see all the layers of the AI. And it was the 30 billion parameter model I did it on. Or was it the 7 billion? It might have been the 7 billion. I don't know. I printed out a spreadsheet. I still have the spreadsheet. But I kind of dissected it to look at it a little bit. And yeah, it was pretty interesting. I think there was like 30 some odd layers. And when I say layer, like, you know, basically like, think of like a multi-dimensional vector. There's like basically 30 of those stacked together. But the point is, yeah, it was pretty interesting. 70 billion parameters that thing was trained off of. And it was also fed basically a big chunk of the internet, which is a lot of, you know, where people are getting information to train these things. And that's largely what I think GPT was trained off, OpenAI's ChatGPT models were trained off of, was like GitHub data and like GitHub code. So yeah, just very interesting. So. Okay, I'm finally almost done. 15 to 16. Then I can go work out. I did a run, I did a couple miles this morning. Now I have to go do my second workout for the day. And man, am I really looking forward to finishing this home stretch of classes. I have like a handful of classes left, and then I should be done. Obviously, I'm going to have to keep practicing. It's never ending. It's also my first like stream where I've been spending a lot of time trying to set up my stream. And, you know, I find it really interesting. It's pretty useful. I live in kind of a remote area at the moment, so it's kind of nice to be able to have an outlet, because it's not necessarily a scenario where I can easily go meet with other people. I am from Denver, Colorado, but I do not live in Denver, Colorado at the moment. And whether I go back, time will tell. Alright, so V1 and V2, that should be the last one. Okay, let's check it out. Okay, so we start here and then we go here. So I'm gonna delete that. We went there and then we went there, and then we went to 6, and from 6 we went here. So we should not visit a node more than once. But some nodes can connect to other nodes. So when we went here, we shouldn't go in a circle is what should not happen. So as I can come to a dead end, but I cannot go in a circle. So if I'm like cruising along my route and then I find that I run into a node that I've already deleted the data from the inside of, then that means I've gone in a circle. I have not gone in a circle yet, but I've come to a dead end here, so I'm going to backtrack to where I was able to have a split. Like this one's a split. You see it's got one edge going this way, one edge going this way, one edge going this way. As long as, like I said, I don't come into a node after I backtrack and then go forward down a path that I haven't gone down. Oops. Okay, so we'll backtrack. Okay, we came this way, we came this way, we came this way, came this way. Okay, that was a dead end. We already went that way. Okay, so it looks like we've gone all the ways that we can go. With this one, that was a dead end. Okay, so we'll have to backtrack here. So we went down this edge here, so let's go down this other edge. This is where we started. Okay, there's that. And then we go here. And then we go around here. This one can only go here. And then this one goes here. And then this one goes to here, here. And that's a dead end. Oh my god! It worked! That's correct! Nice! We did not do a cycle. Dude, that is so great. Thank you, Kruskal's algorithm. Alright, well that's it. I verified it's correct. So that is the implementation of Kruskal's algorithm. Thank you to my professor at Florida International University for the code that he basically helped us to implement and we wrote together and went over for Kruskal's algorithm. I hope this was useful, and I hope everyone has a great day.